Ready to go?
Yeah. Yeah.
All right, let's get started. Okay, so we're almost at the halfway point of the semester. So you're working on PS6 now, and then that's due soon. And then midterm is a week from today, so we'll do a review in class next time on Tuesday, and the midterm is on Thursday. Also tomorrow, PS7 will come out, your first pair assignment, and that'll be due in 2 weeks. So who here still needs a partner? Okay, so when we take a break, why don't you all come down and introduce you. Go over there and have a powwow, maybe you can find a partner. One thing I should say is, when the assignment comes out, the first step is going to be to register your partner. So even if you don't plan on starting the assignment anytime soon, I'd appreciate it if you at least do the registration step. That way I can see, who isn't getting paired up to take action. Are there any questions or problems about PS6 or anything else? Yes?
How will we be sharing our solution with PS7?
Oh, that's a good question. He asked how their partners can work together, basically. How will they share? What I'll do, one reason I'm having you register as a partnership is I'll create a shared repository for you on GitHub. So you'll have a shared repository, and that's how you'll turn things in. But you'll be able to. You have to sort of get GitHub to the next level then, because you'll be working with one other person. You got to keep things straight. There were a few messages before class about half an hour ago, 45 minutes ago, about how people all of a sudden having trouble committing to GitHub. I was too. I'm assuming I'm hoping it's a temporary GitHub problem. Nothing more serious, so hopefully after class that'll be all good. Any other questions? Okay. All right, last time we were talking about the HTTP protocol, and then we started talking about RESTful services. And today I want to show you more about that. So what I got up here is called the Advanced REST Client. It's I think it's called a plugin. Anyway, it's sort of like a plugin of Chrome, the Chrome browser. So it's a free thing. I imagine you have to have Chrome installed first, and then you go find the Advanced REST Client and install that. And what the Advanced REST Client is designed to do is to let you interact with remote web servers and see what's going on. So it displays, it's not working as a browser, it's working as a tool to let you see, let you be the browser. So let me just show you what I mean. So what I'm going to do here is I can pick what kind of request I want to make, a GET request, a POST request, and so on. So I'm going to make a GET request. I can type a URL there, so HTTP : let's see how it's doing, www.utah.edu. Okay, so that's my URL. And then I can send it. And it'll show me what comes back here. So you can see what comes back is all this stuff. So that stuff, when it's displayed in the browser, is what you see when you visit that web page. And you can even go here and click on this little eyeball, and it'll sort of show you what it would look like. It doesn't really get the CSS right, the formatting right, but it gives you a rough idea of what the web page would look like. And then we can do other things. We can look at details here, and you can see what really came back. So what came back, the response code, when there's an HTTP response, there's a response code. In this case, it was 200. We can see the response headers. So these are the headers that came back, that were given back to the browser from the server. So it said, the page was generated on this date by an Apache server. It was using the chunked transfer encoding, and the content type is text/HTML. So that'll show you the response headers that came back. Up here, we'll see examples shortly where we can actually, we did not include any headers with our request. We didn't have to, but we could have. Now, if you go, let's say, to Google, you can do the send, and you can see what comes back. So it's got a bunch of different, it has more headers than the use server sent back. And then the response looks more like a program than HTML, and I think, in fact, that's what it is. It looks pretty obtuse, and if we view it, we see something that sort of looks like a Google page. So we can interact with any server we want, but we do it at a low level of the way a program might interact with a server. So we're going to use this to learn how REST works. Right? So, first step is I thought I had a page up, but I don't. So I want the Github Rest API. And it's right here. So GitHub, along with Canvas and lots of other places, provides an API that lets you write programs that interact with their services, in addition to just using it through their web page. And so what we're looking at here is the front page of the API for using GitHub via a program. So what I'm going to do today is I'll show you through the Advanced Restclient some example interactions with this API. And then we'll look at the same interactions in a C# program. And these are the kinds of interactions you'll be doing starting with PS7. PS7, you'll be writing a client to interact with a REST service I'll give you. And then in the next assignment, once you have the client, you'll be creating a server of your own, a web-based service of your own. So you'll first be a consumer of REST, and then you'll be a provider. So there's a lot to read to master the API. It takes some poking around and figuring out, how it's all organized. But I've sort of pre-digested it for you. There's like over here on the left is a bunch of high-level explanations about the API. But the first example I want to show you is to list. I'm going to show you. Let's suppose you want to know all the organizations you belong to. For example, you belong to my organization for the class. So if I click on organizations, it'll take me over here, and then it says right there, list your organizations. So I'll click on that, and here, what it gives you here is the call that you need to make. So the URL that you send to the server is /user/orgs. You have to put in front of that, you have to put the name of the server, which is the same for all these calls. So if you issue a GET request and use that as your file path, it's telling you that what you'll get back is, assuming everything is right, you'll get 200, okay. And the body, so your status code will be that. The body will look like that. So the body of the response will look something like that. Now what is that we're looking at? That's JSON. So that is a JSON encoding of an object that was created on the server. So an object answer was created on the server, encoded into JSON, and sent back in the response, in the body part of the response body. And so the way to read this is meant to be a typical response. Square brackets mean list. So what it's telling you is that you'll get back a list. And what's contained in the list, these squiggly brackets, that's an object. So this shows a list of one object, but in fact, you're asking for all your organizations. So you're going to get back a list of 0 or more objects. All right? You can expect each object to have a login property, an ID property, a URL property, and so on. So it's telling you what sort of object you're going to get back, so that when you get it back, you'll know how to take it apart. Like if you want to look at an organization, you have to take what you get back this JSON object, you'll convert it into a C# object, and then you'll have a list. And the first element of the list will be an object, and that object will have these properties. You can access them in the usual way. So that's what you get from reading the documentation. You know what sort of thing to expect, and you know how to ask for it. So let's go see an example of asking for it. So I'm going to go back to the REST client, list all my organizations. So I've predefined I've already did this before class. So let's see what I've done. A GET request, because the API said to issue a GET request. The URL, the API said to use /users/orgs. To that I pre-pin https://api.github.com, because that's just the name of the server. So that will be the beginning of all our requests. Now, I didn't show you, but elsewhere in the documentation, it talks about what headers you're supposed to include in any request that you make. And I am including 3 headers here. I'm including this thing here, this accept header. So I just type this into the client. And just the documentation says I should use that as the value of the accept header. Basically, I'm saying I'll accept JSON from you. It asks me to give as the user agent my email address. So typically the user agent identifies the browser. It asks me to use my email address. So I did. And finally, there's got to be some kind of security here. You can't just use this API to get information about anybody's GitHub. So what I have to do is include an authorization token. I use the authorization header. This thing here is a token that was generated by GitHub for me. And so if I include it as the value of the authorization header, I put the word token followed by the thing that GitHub gave me, then I'm authorizing it to work as, to treat this request as if it came from me. So if you could read the entire token right now, I've deliberately squished my screen so you can't, you would be able to, until I revoke the token, pretend to be me. Okay? Now, as for where that token came from, if you go into GitHub and you go to, well, I've sort of skipped ahead here. Let me go back. Okay, so right here I went to my picture, I went to settings. Under settings I went to security, I think. And, oh shoot, that's not the right place. No, I went somewhere. What else looks promising here? What users, repositories? Yep. No.
The keys, SSH.
What's that?
SSH.
No, it's not the SSH. Session security. Well, I guess I shouldn't have backed out of all that stuff. Was it headed? Oh, it's developer settings. So developer settings, personal access tokens. And right here, you see it says classroom demo right there. That's the token that I generated before class to use. And it's not showing it to me. I copied it and pasted it. And now all I can do is I can delete it here. But if I wanted to generate a new one, I would click there and go through the directions. So you can create tokens and then you can get rid of them. You can interact with the structure with Canvas in the same way. They have their own way of generating tokens to do the access. So anyway, it's using that form of authentication. So if we go back to here, so by using a GET request, using the right URL, setting the right headers, I should be able to send a request and get a response back. Okay? So back comes a response. It says it was an OK. And then we can come down here and look at what came back, and what do we see? It says it renders it slightly differently than if it was raw JSON, and I wonder if, try that. Oh, okay, that's formatting it. Okay, this is the raw response form, but that's kind of hard to look at as well. you can see that it's an array, object, there's a login, there's an ID, there's a URL. So that's the raw JSON, and we just scroll, 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 scroll. We're getting a bunch of objects back. If I go back and reformat it with text wrapping, okay, it's a little easier to see. Or maybe I'll just go back to the table view. This is just giving you a different way of looking at it. But in any event, what you're getting back is a JSON string that has, in this case, 5 organizations, login name, ID, URL, and so on. And so if we were writing a program, we could access, take apart the list, take apart the objects, pull out what we wanted about the organizations. So that's a simple use case of a REST request to the service provided by GitHub. Okay? Does it make sense? Any questions? We'll look how to do it in C# later, but that's our first view. Okay? Let's see, that's list all my organizations. Now let's list all users. So we'll list all users on GitHub. I'm going to turn this back. That's more like. Okay, so let's look at the what I do up here. If I go to the API, I see that I got to issue a GET request, and it's supposed to be just /users right there. And there's supposed to be there's an optional parameter I can include. It's since 1, 2, 3, 4 is what I did. Who could guess what that's for? That's how you pass a parameter to a GET request. So it's like passing a parameter to this method. What do you think? Yeah?
Only gets the users with a numeric ID higher than that.
Exactly. It says start with user 1234 and go forward. Okay? So, I've got, if I look at the headers again, I've got the same sorts of header set that I had before. The accept, the authorization, the user agent. I can say send now. And I get back the response. And this time I got an array of 30 users. So Hugh is a user. Crate is a user. Durbin is a user. And so on. You think there's more than 30 users on GitHub? Yeah, quite a few more. And it turns out if you read the API, if there are more users, then it could report. So it doesn't report all of them, it just gives you a chunk of them. If you look in the headers, there is a information about how to obtain the rest, or obtain some more. So it's the format is getting kind of screwed up. But up there, there's a header called link. You see that header right there? Link. And one of its values is that URL. And then after that, it says rel equals next. So what that's telling you is, if you want to get the next batch, use that URL. So if we're writing a program to do this, it would have to look through the header, the response headers that were sent back in the server, looking for a link header, and seeing if that link header had a next link in it, and then sending that. And so if I were to take this here and just copy it, then it would give me the next batch of probably 30. So I could go back up here now, get the link it gave me, send it, and back comes another batch of users. That's how it handles. If there's thousands and thousands, it doesn't want to send you that whole array back. It just sends you back a bit at a time. Okay. So there's another simple example of using the API. It's a matter of reading the documentation and then knowing how to handle all these details, how to set the headers and how to set the request and so on. Okay, the next one is list all commits on a branch of a given repository. All right, so let's think about that. I want to see all commits for a particular branch on a particular repository. Right? How can a URL express all that? Like, how's it going to specify a particular branch? Or how's it going to specify the particular repo? And you know, repo names aren't unique on GitHub. You know, they're unique to an individual or to an organization. So something more complicated is going on here. So let's go look in the API and see how what's required to do that. So API is over here, and what I want to find is, let's see, repositories ought to be over here somewhere. So I'll go to repositories, list your repositories, or list, let's say list user repositories. List organization repositories. No, I don't want to list. I'm confused now. What did I want to list?
Commits on a branch.
Commits on a branch. Okay. Let's look up here. List repositories, create, get, edit, list all topics, list contributors, list teams, list tags.
There's branches on the right side of the repositories.
On the right side, there's branches. Where is that?
Under repositories.
Oh, okay. Commits. How about that? List commits on a repository. Okay, that's looking more, thank you. That's looking more helpful, more hopeful. There's our URL. So, you know, I remember the first time I saw this, I was wondering, what the heck, what's this mean, :owner and :repo? What do you think? Yeah. Right. So when you see something like this, there are various notations that are used. That means you don't literally put :owner. It means that you put, in this case, you would put the username of the owner there in the URL. So the URL then would be like /repos/JosephZachary/ name of repo, examples, /commits. And so that's the URL for obtaining all of my information about my commits on a particular repo. All right? So sometimes, the way these REST interfaces are written, the parameters, what you think of as parameters to the request, have to be embedded into the URL. Down here are other parameters, like SHA and path and author and so on. Let's look at SHA. It's the branch to list the commits from. So if you don't say otherwise, it's going to list the commits on the master branch. You can change that using an optional parameter. So, having figured all that out, sometimes I'll show you an example. No, they didn't. But I'm kind of here to see what kind of response I'm expecting. So it's, it's showing I might get a whole bunch of answers. So you'll be using that link idea. And then for each commit, I'll find out stuff about it. So I'll get back a list of commits. And one commit's actually a pretty long thing. So let's go see what that looks like now. So I want to go to list all commits on a repo branch. So there's our start. We got /repos. And I'm not looking for my repos. I ask it to show my organization's repos. So I put that as the username. And then spreadsheet, that's the repo I want to see. I want to see all the commits on the spreadsheet. So there's my URL. And then remember there's that parameter SHA, where I could give a hash code, or I could give in this case, I give the name of a branch. So I'm asking for the PST branch. So that's how you compose that. It's just a matter of reading the API and understanding what it's asking you to do. So I put the URL that way. I've got the headers here. Got the three headers, the standard three headers that I have. I send, and back comes all that information about commits. There's something, let's see, it says there are 6 commits to show. So I get that all back. So there's another example of a GET request. Now while I'm at it, what happens if you mess up? What if you spell something wrong? You're going to send, and you get back a 404. Sometimes, oh, here's another example. Let me go back and fix that problem. But this time, let's send back a bad token. So now it's a bad authorization token. So I'll make the same request, and it got back a 401 unauthorized. So when you read the documentation, you'll find out there's circumstances. It'll tell you what response code it gives you on success. There are various response codes it can give you if you screwed up. And so by looking at the response code, you can figure out something. And in fact, along with the response, it sent back a body that says bad credentials. It points you at the documentation. Okay, so so far so good. Now we're about to look at a different kind of request, so tell me if you have any questions. Now's a great time to ask. Next request is a request right here to create a public repo. So I'm going to create a new public repository via a REST call to the GitHub server. So let's go consult the documentation. That would be under repos somewhere. List your repositories, there's create. So to create a repository, it says issue a post request, and the request should be /user/repos. Clear enough. But there's additional input you give it. You can give it the name. It's required to give a name to the repo. So you give a name whose value is a string. You can optionally give a description or a home page, or whether you want to set it to private or public, and so on. So these are telling you how you can configure the repo. Okay? Now with a post request, you have the URL. Extra information, this configuration information is sent in the body of the request. So just like a response can have a body, a request can have a body. So what you do is you create a JSON object that contains the information that you want to pass in, and you send that along with the request. So if you want one called Hello World, you create an object with a name, property, Hello World. Description, this is your first repository. And so you fill out the object any way you want, stick it in the body of the request, send it to the server as a post request. So GET requests don't have an empty body. All the information is in the URL. Post request, the information is carried in the body. Okay, so let's see what I did. There's my URL. It's a post request. And look down here. What you see right there is I just typed in a simple JSON object that says name, demo repo, description, classroom demo. And I'm making that the body of my request. I'm getting help from the REST client. So now I can send that, and I get back 201 created, and it sends me back information. It sends me back a single object this time that contains all the information about the new repo I just created. So that's a post request. Now, let's say instead I did a post request, I did a GET. I'll send that and see what happens. Well, it worked that time. That's kind of odd. It's probably a different, oh, yeah. So it worked, but it ignored the body, and it's just getting information about repos. Probably giving me back all public repos there are. So it matters what verb you use here. Okay? So typically GET requests just get you information without modifying anything at the service level. Post is used to create new things. Put, which we'll look at next, is used to modify things. And delete is meant to delete things. All right? But I get this uneasy feeling because I've been talking nonstop for too long. Is it just all really clear and obvious, or is it just all completely confusing and obscure? Yeah?
So is GET the only form of request that doesn't have a body or has an empty body?
It's the only one that's, I believe it's the only one that doesn't have a body. Yeah. Yes?
Why do we use this?
Why do we use what?
The utilized rest.
Okay, so he's asking why we're using the REST client as opposed to using what?
So I'm not understanding why. I think this question is, what's the point of using this at all?
Okay, why use the API? Okay. All right, who knows the answer? Why bother with this at all? Yeah?
Because we want to build applications that talk to each other over the internet.
Yeah. If you want to make an application that that interacts with GitHub and provides some service to someone. Okay? Maybe you want to write a plugin for Visual Studio that supports Git. So probably the way that your plugin in Visual Studio interacts with GitHub is via this API. Okay? In my case, I write all kinds of scripts of programs that run against Canvas API because the user interface of Canvas is a load of crap. And it doesn't provide everything I wish it did, but the API is more full-featured, and so to get things done I can't do otherwise in the interface, I go in the back door and write programs that directly interact with Canvas via its API. Now, in your case, you're interested in REST because assignment 7 is a REST client. Right? You'll be writing a game, an interface through which a user plays a game, and it will have to interact with a remote server via REST. Okay, so that's what REST interfaces are for, so you can interact with services on the web. What's this for? What is the advanced REST client for? Why are we using it? That's another question. Yeah?
Makes everything way easier than using it.
Right. It is just, yeah, he says it makes it way easier than using a command line. Essentially, it's nice, say you're writing a program, and I'll show you my program later that does the same sort of thing. And you want to interact, you want to make some REST calls to some API. It is really a lot easier to debug your REST calls here, play around with them until they work, and then put them into your program, than it is to put them into your program and try to debug them when you're running your program. It's just more direct here. So what I encourage you to do is, when you get assignment 7 and you figure out what REST calls you need to make, experiment with them in the advanced REST client so you can learn how they work, see if they're working before you try to put them into your program. Yeah?
Is there a name of the language that you program in this client?
C#.
Oh, it's C#.
I mean, you can interact, any language will let you interact with a REST client. You can do it Java, C#, C++, Python, what have you. You'll be doing it in C#. I mean, the stuff I'm typing here is not C#. The stuff I'm typing here will show up in the C# program. Yeah?
Will this be PS7 or PS8?
Oh yeah, PS8.
Okay.
The one after PS7, sorry. Don't mean to freak you out. Okay, any other questions? Yeah?
Is there a reason you're using this REST client as opposed to like a different one for testing?
Yes, because it's an advanced REST client. No, I'm using this REST client just because it's the one I use. And it works well for me. Yeah?
Under the method section there's the drop-down menu to list all the commands. Are those all the commands of REST, or is there really just a rabbit hole where there's more?
The drop down, you mean up here under, right here under method?
Yeah.
No, these are the, at least, yeah, they're just a handful.
Okay. So
And we won't use more than get, post, put, and delete. Those are by far the most common. And get and post are by far the most common of those four.
follow-up question, all those things are specific to REST?
Well, they're specific to HTTP.
Okay.
And REST is sort of layered on top of HTTP, so it just inherits what HTTP provides.
Okay.
Right? Well, there's two more, but we'll take a break and let you rest your eyes for a minute, and then I'll show you the two more. question.
Yeah, going back to like APIs, why do a lot of websites like not have APIs?
Okay, why do not a lot of websites have APIs? Because they don't want to support them. They, you know, it's a it takes resources to support an API.
Okay.
You know, programmers and machine resources. So. Okay, so rather than go through the next two examples, I want to loop back just to hopefully help out with some of the questions people have of what this is all for. We're going to look at the same types of requests, the exact same requests that I was making via the REST client. Show you how they would work in C++. So I have some methods, get demo, get all demo, get with params demo, and so on, that correspond exactly to the sequence of advanced REST client examples I've been going through. So this code here will be stuff you're going to look at when you work on PS8. It's got lots of comments in it, so I'll have to highlight the code that isn't comments. This first method, to communicate with a remote client in C+ and C#, you need an HTTP client. You have to create an HTTP client. And you know, it's easy to create. You just create a new HTTP client. And to communicate with GitHub, there are various things properties that client needs. For example, we have to set the base address to the address of the server. Okay? We have to set those three request headers that I kept using in the advanced REST client. So right here you can see I'm setting the accept header, I'm setting the authorization header, and I'm setting the user agent header. So that way, whenever I create a client to communicate with, it'll have these headers already set. Now, you of course won't be communicating with GitHub, you'll be communicating with the server I'll provide. And so what this method would do in your case would be different. But in this method, I just do all the initialization that's going to be common to every request I make. So it returns an HTTP client. So here is our first example, the very first get example. So what I do is I open a client right there. Client equals create client. Why am I doing it in a using block? So that when I exit the block, it'll close automatically. I don't have to worry about closing it myself. So it's just a resource that can be automatically closed. Okay? Next line of executable code is right here. You call client.getAsync. That's the URL. User orgs is the URL from the API. .result. Okay? Now, this getAsync is what's called an asynchronous method. We'll talk about asynchronous methods later. But for now, all you have to know, if you want to call an asynchronous method, until further notice, after you call, whatever the result of the call is, you need to put .result at the end. And that synchronizes it. So just take that for what it is right now. So what this does is it contacts the server via this URL and gets the response and puts it in that variable right there. So now we have the response. If you were single-stepping through this, you would see that this statement takes a few seconds to execute. Because it has to set up the connection, contact the server, get the response back. That takes a fraction of a second or a second or two. All right, so we've issued the request. Now, the response object comes back with a status code. So right there I'm saying if the response had a successful status code, I do one thing. On the other hand, maybe it failed, else failed. And in my case, if it fails, all I'm doing is writing out an error message with the reasons that it failed. If you're writing a real interactive client, you might want a window to pop up and say, request failed, please try again or something. You might want to log the message so you can tell what went wrong in the future. But in any event, you have to unlike a regular method, I guess it's similar to a regular method call. Regular method call, you might have to catch exceptions. That's sort of what's going on here. Okay, so back up to the response part. That line right there, it says response.content.readAstringAsync.result. What do you suppose that does? Yeah?
It puts all the return data into section.
Yeah. It it just grabs the response body, which is a JSON, an encode, a JSON object in string form, and stores it in that variable result. Okay? Next thing I do is I call a deserialized object method on that string. So I've got a JSON library, and what it does is it takes result, which is a JSON, the string form of a JSON object, and deserializes it, meaning it turns it from string form into an internal form. It turns it into a C# object. Now, what type of object do you suppose it turns it into? See, the problem is it needs to turn it into a type of object that has the properties that are needed. The properties that we get back sort of depend on what the server put in, what properties the server put into the object. So it's hard to match up the exact response type we're going to get back. So what it's doing is it's creating an object, all right, but you don't know what the type of the object is. And so you can take an object like that. You don't know what exact type it is. You can store it into a variable as long as you call the variable dynamic. The type of the variable is dynamic. A dynamic variable in C# can contain anything. You can store an int in it now, and then next time you can store a string in it. Next time you can store an array in it. Next time you can store a list in it. Then you can store a double. You store anything you wish. Right? That's different from var. What's the difference between saying var orgs and dynamic orgs? Let me get yours.
When it's var, then you have one type.
Okay.
But if it's this,
When you declare var, what you're saying is, I know the type, and the compiler knows the type. I'm just too tired to type it, to actually write it with my fingers. And so there really is only ever a single type of thing stored into that variable. It's just that you're not explicitly saying what the type is. Dynamic is the way it sounds. You can put anything that you want. Now, when you have a dynamic variable, you are sacrificing type checking. If you misuse it, let's say you have a variable, a dynamic variable, and you store a string in it, and then you try to add 7 to that variable. The compiler won't complain at all. It's not until the program runs that you find about the type error. Okay? So that can be a little disconcerting when you're used to compile time type checking. So anyway, we get some kind of object back. Don't know what type it is. We store it in that dynamic variable orgs. And then, what my program does, it prints out, it says my organizations, and then it iterates through orgs, pulls out, so it pulls out something, that's another dynamic variable, and then it prints out org.login. So what it's going to do is loop through all the organizations and print out the login name for each organization. Now, how do we know this will succeed? How do we know we can write a for each loop that works with an orgs, with this dynamic variable? Huh?
Because that's still dynamic.
Yeah, but if this turns out not to be a list, this is going to fail. We'll get an exception at runtime. Maybe orgs may contain an int for all we know. Yeah?
Well, we know it works because we read the API there.
We read the API, and we know we're expecting to get back a list. So we're willing to say, okay, since the API says we're getting back a list, this will contain a list of things, and it's okay to do a for each loop over a list of things. So this is going to be some kind of thing. Now, how do we know it's safe to get the .login field out of it? Because the API said the things the list contains will have a login property. And so we're able to access it there. So if the API is accurate, we're fine. If the API is wrong or we misread the API, it may turn out there's not a login field, but we won't find out about it until we run the program. That's just dynamic type checking for you. So that's how you'll be interacting. You won't be able to rely on IntelliSense to find out what type of objects these are. You have to rely on the API. So this is a service. Maybe you want to sell a service to someone, a program to someone that will list all their organizations on GitHub. And this is the kind of program that would do it. It fires up, accesses the remote server, gets the information back, summarizes it. Simple GET request. Okay? So a lot going on there. I mean, there's this new dynamic idea where you get dynamic type checking in the middle of a usually statically typed language. So that's one twist we got here. And it's a good thing they have that, because otherwise, for every time you want to do a new request like this, you have to define a new class of data, a new class of object that had just the properties that are provided by the API. And that would get old pretty quick. So we don't bother with that. All right, let me see what questions there are. I promise you, you'll have questions. Either you have them now and get them answered, or you have them in 3 weeks. But one way or the other, you'll have to figure all this stuff out. Yeah?
Is there a way, after you declare like a dynamic, to look up the properties of like words?
I suspect there is a way to interrogate that object and find out what type it is and what field it has. Yeah. I've never done that though. Any other questions? All right, well, let's look at the next one. This is the one where we're getting all the users off of GitHub. So you can see I'm creating my HTTP client. I am issuing my request, which is /users $since equals 46. I'm asking for all users with ID numbers 46 and higher. I'm getting my response back. If it was successful, let's see what I do. I grab the result out of the body as a string. I deserialize it to an object, so I got dynamic users. Then I loop through, I'm hoping users is a list, so I loop through lists. And I'm hoping that the objects in the list have a login property again. So I'm just printing out the login names of all the users. So that's pretty much like what we did before. Now remember, it may be there's more users yet to come. It only gave me 30 when we tried it out. So this last bit of code is just an example of how to go into the headers. So we go into the response headers, pull out the value of the link header, and then we iterate through all the links that are in there and print them out. So it just shows you how to take apart that in case you need to extract the next link and work on it. So again, it's just coding like any other coding. You just have to know the lay of the land, how to access these remote APIs. Plus you have to understand the remote APIs. This next one, remember there were parameters that had to be passed. So let's look right here. What's going on with this string.format? Yeah?
Basically, putting the two or how many like variable arguments you're basically injecting into that string where you indicate an index.
Right. Remember the API said inside the URL you got to put some information. So in particular, right after repos, we've got to put the name of the organization. That's what org is. And we've got to replace this thing here with spreadsheet, which is the repository we're interested in. And finally, right here in the parameter stream, we've got to have PS2. Now, just to be on the safe side, I'm essentially escaping. PS2 is fine. Some things, some special characters can't appear in a URL, so I'm just, as a general rule, that's how you process it before you stick it in. Do that URI escape data stream. So that builds the URL I'm going to call. So then I call it, and if I'm successful, I grab the string body, I turn it into a list of commit objects, and then I just, I didn't even iterate through it that way, I just printed them out. Okay? So those are all pretty much the same. Those are your 3 GET examples. GET examples. Right? Here's our post example. Now there's something else new. what do I do after I create the client? What the heck is an expando object? I could have lost a lot of money on a bet that C#, I couldn't imagine that C# would have a built-in class called expando object. But lo and behold, it does. What do you suppose an expando object is? So I'm creating an expand object. I'm storing it as dynamic. Then I say data.name equals demo repo. Does that mean expando objects are objects that have name, description, and has issues properties?
Not necessarily.
So what are expando objects? Yeah?
You can define fields of the class as well.
Right. Somehow they have this ability. They just take whatever form you want them to. So you create the expando object. It has no properties. But when you say data.name equals demo repo, lo and behold, that object suddenly has a name property. So the fact of assigning to the property creates it. So it's sort of the opposite of what we were doing before. We're getting back something and turning it to an object that we didn't know what the properties were. Here we're sort of creating an object with no properties and then magically populating it with properties. But still, you have to do it through the dynamic type. So we want to have an object with name, description, has issues, create an expando object, assign the properties, and we're done. Now, why are we doing this? Why are we creating that data object? Yeah?
Perhaps that's what the API is expecting.
The API wants us to encode a JSON object and include it as the body of our request. So let's see what I do. I create that data. Those are the sort of the parameters going up to the post call. Down here, I'm serializing the data object. So I'm turning that data, conceptually, I'm turning the data object into a string, a JSON string. And then I've got to turn that into a string content object. So I take that, I use UTF-8 encoding, and that's the type of data it is. And now I have a content object. So that's all. That entire line of code is just boilerplate. You'd always encode an object the same way. Then I do client.post async as opposed to get async. I have the URL, plus I have the content string. And so it takes care of putting the content string into the body and passing it up. I get the result back, and I take the result apart, just like we were before. And so now, when I take the result apart, it's just deserializing it and then dealing with it like before. So that's the example of a post using an expanded object. Yeah?
So if we wanted a method to return a dynamic object, would the return type be dynamic or expando object?
I've never tried actually declaring something of type expanded. I would just use dynamic.
Okay.
But perhaps expando object would work. Yeah?
Can an expando object do anything and just do things that JavaScript objects can do?
Yeah, what expando object is just for having properties, nothing else. Now, it may be, on rare occasions, you want to have an object with a property which isn't a legal C# property. So let me show you what I mean. Suppose someone said that you wanted to have a field called data.123. Well, that's just syntactically illegal. Right? You can't have a property name called that starts with a digit. But maybe the API insists that it wants you to do that. So you can do this. Okay? That's effectively like saying data.123 equals hello. So it creates a property called 123. So you can set properties that way and access them that way if you need to. Usually you don't need to. Okay? Any other questions? Okay. Now here's one we didn't look at yet. Let's look at it here, and then we'll look at it in the Rest client. This is a Putt request. So puts are typically used to change remote resources, change an existing remote resource. So let's see what I'm doing. This one wants to commit a file to a repository. So we have a repo we've created. We want to put a file in it, commit a file to it. So I create a dynamic expando object there. I give it a message and a content. And it said in the documentation that whatever the content of the file was, I had to encode it as a base 64 string. So anyway, I just called the right methods to do that. I create the URL. The URL says /repo/ my name, or /1 /demo repo /content /file1, which is the name of the file. So API just said I need a URL like that. I package it all up. I do the put along with the content that goes in the body. That comes either success or failure. So that will actually commit a file to the repo on GitHub via Putt request. Right? What do you suppose it'll look like in the REST client? Let's look. Here's my put. So here's the URL, repos /Joseph Zachary /demo repo /content /file1. In the body, I have this JSON here, message committing via API, content, that's the base 64 encoded content of the file. And when I run this, I've got the headers here. Content type, except, here I need, content type says what type of data I'm sending up. And that should create for me. So if I click send, it says create. If we want to GitHub right now, we would see it created a file and committed it to the repo that I created. And the final example is a delete, which is used to remove resources. And I don't believe this, I think this body here is not necessary. I think that's just left over from a different example. Anyway, the delete URL is just, we say repos /Joseph Zachary /demo repo. The verb is delete. And when I send it up, it succeeded, 204. No content means there's no body. So it deleted that thing for me. And back in the world of C#, that's what it looks like. We create the URL according to the API to delete that repo, and we execute it and see if we succeeded or not. Okay? So let me just tell you, the experience of working with a REST client is going to be roughly like, in PS7, you're going to be writing a client, a spreadsheet GUI that communicates with your spreadsheet class. Imagine if the spreadsheet class didn't exist, it was a service on the web. Suppose all the methods that are provided by the spreadsheet class were instead provided by a REST API running on the web. Then your GUI, instead of making calls to your spreadsheet object, would be making REST calls to the client in the sky. That's what PSA will be like. I'll give you the client in the cloud, and you'll write, I should have said the server in the sky. I'll give you the server in the cloud. You will write a client that communicates with that server, that service, via REST calls. That's why it's important to begin to understand it. Now, I have slides here that is basically screenshots I went through the demo I was going to do and made screenshots of it so you could look at it later and see exactly how I use the REST client. So you got that to work with. So you can see how to use a REST client. You can see, you'll have the code. The code is in the examples repository, so you can see the code that I used. And all that's left is to say a little bit more about what a REST service is, what its purpose is. But before I look at these last few slides and talk about what a REST service is, are there any lower level questions I could answer still about issuing requests and dealing with responses? Yeah?
I have a question. I've heard of SOAP services or APIs, or is that pretty similar to REST? Or different?
Right, so there's like, you hear about SOAP and WSDL.
Right.
Those are older approaches to doing web services that are based on XML. And the way those older services work is they assume that to use a service, you had to have a detailed description of the type of data that you would get back. And so there were these detailed XML descriptions of the data returned by each remote call. And you could use those descriptions of the data to actually compile them into classes in your own programming language. So with REST, they dispense with that part. Instead of getting XML encoded objects, you get Json encoded objects.
Simplified.
And instead of a formal description of what the data would look like, there's just the API documentation that you can apply. So it's a simpler, more streamlined approach than the older SOAP approach. Any other questions? All right. So to use a REST service, you need to find the API. So that's what we've been using. That's the API for GitHub. This is the API for Canvas. So if you're frustrated with Canvas and you'd like to write your own little scripts to pull whatever out, you can do it through that API. Once you figure out how to implement a REST client, you can deal with Canvas that way if you like. And like I say, I've done a lot of that because there are things I can do that way I can't do any other way. So there are lots of services you can find out there. Now, with the REST service, what you're thinking about is the servers are maintaining a collection of resources. So GitHub is managing users and organizations and repositories and teams and commits and so on. Canvas is keeping track of assignments and submissions and grades and files and classes and users and so forth. So each of them has some set of resources that they're managing, and they're giving you some sort of access to the resources. Remote client always operates by naming a resource. So they're usually set up so the URL names some resource. So it's specific it needs to be to name some resource. Then there's some action, usually a get, a post, a put, or a delete, that you want to perform. There are some parameters. Sometimes the parameters are embedded in the URL. Sometimes the parameters are after the question mark. Sometimes the parameters are in the request body. But they're parameters and they're sent up. And then you receive a response containing your result, typically encoded in JSON. So that's what they all have in common. Experience is kind of the same from API to API. So we looked at examples there, so I won't repeat this. It's just showing a few others. And I'm going to skip through. These are, again, different examples of things that we may or may not have done those examples today. But there's a separate set of slides that contains exactly the examples we did today. Okay, so the Restful Architecture, REST stands for Representational State Transfer. Like I just finished saying, it's a simpler way of providing web services compared to older things like SOAP. So it's what's very common today. Typically, you consume them via HTTP. So REST servers are built on top of HTTP servers. And REST clients have to use HTTP to attach to it to access the servers. And HTTP is ubiquitous, so that makes sense. You don't invent a new protocol to do what's already being done okay. You can think of the World Wide Web as an example of a RESTful architecture, in a way. It's not exactly, but the remote servers have they have resources you want to access, mainly web pages, and you have different ways of accessing different web pages. So you can read papers about REST, and I don't want to belabor this. It's sort of, if you're sort of a theorist about what REST is and what REST isn't, and you like to argue on Stack Overflow about whether some service is really RESTful, then it would be good to be familiar with all these definitions of what a restful architecture is. But just to summarize, it's client-server based, where the server maintains the information. The client provides user interface. There's sort of a uniform kind of interface where it's based on describing resources. So the URL describes the resource you want to get. When you ask for something from the server, it sends you back a chunk of the resource. Now, and it sends it in a form that may not be the same form it is on the server. So on the server, it's all stored in a database. So the server doesn't give you the ability to query the database. It just, when you ask for some chunk of the resource, it pulls it out of the database, formats it to JSON, and gives that to you. So that's the representational state transfer. It's to transfer a state, representation of the state. If you can get your hands on a resource, then typically you can operate on it. Yeah. Sorry. And the response, I guess you have to say the response contains all the information you need to interpret the response. I should say the response together with the API contains the information you need. It's stateless. So there are no sessions, there are no cookies. It's just you ask for something, it gives it back to you. The server doesn't worry about what clients are out there, how many, what they know, what they don't know. It just, you ask, it gives. It's possible to, you know, just like regular web accesses, responses can be cached in some cases. Anyway, there's a long list of boilerplate about what REST is. These are the claimed advantages of this way of approaching. And who wouldn't be for a system that has high performance, is scalable, simple, modifiable, portable, and reliable? So I mean, if you could convince people that your system is all those things, then you've done a good job of sales, and people will use your system. So that's why I guess the REST was proposed in someone's PhD thesis, and it was a successful thesis because lots of people use it. Okay, so last chance to ask. Any questions about it? Yes?
Where do we get that client?
The client?
Yeah.
Just search, I think you have to have Chrome installed,
Okay.
and then you search for Chrome Advanced Restclient, and you install it. It installs into Chrome. Yeah?
So with it being stateless, as far as paging, it doesn't maintain any information about your query and where you are as far as the page.
Right.
You have to track that index.
Right. The only thing, what it does for paging, it sends you back the next page to ask for, but it doesn't remember internally what the last page it gave you was. Yeah?
Will we have to worry about Oauth or any of those sorts of things?
Okay, so she's asking about OAuth, which is an authorization scheme. So when you log into Canvas, you're using OAuth. You log into Canvas, sometimes you have to type your password, and it creates some credentials, and the credentials have to be refreshed every hour by your browser. Eventually they expire, you have to log in again. If you're unfortunate enough to be an employee of the university, you have to use your cell phone in addition, two-factor authentication. No, you won't. The back door around OAuth are those access tokens. And the disadvantage of access token is, it's not very secure. If someone steals it, then they got it. But it's a lot simpler than writing code to manage all I just described. Plus, the service I'm going to give you is essentially insecure anyway, so just don't worry about security. Yeah.
I imagine it's possible to use REST requests from within a program to get an authorization token if you have the other credentials.
Yeah, and in fact, so I wrote a plugin. I mentioned this. I wrote a plugin for Eclipse to help with handing in assignments in 14.10. And the student that did it for me had to master all the OAuth stuff. And it's all using REST calls. And popping up a browser at the right time. Yeah?
So these are all HTTP requests, or is there like HTTPS requests?
Yeah, in fact, all the examples I did at GitHub were via HTTPS.
Okay.
It just depends on what kind of server you use. Yeah, HTTP, HTTPS, I use them interchangeably. It's just whether there's an encryption layer or not. All right, now, we're right at the midpoint of the semester. I think actually Tuesdays will be over the hump. And it's easy, you know, you get ground down on the semester and things seem overwhelming and you're struggling with PS6 and you're worried about PS7 and up here reacting about PS8. And it just seems like the way the world is about to fall down on you. So I just wanted to encourage you and tell you that in my experience, after PS6, things start to ease up a bit, believe it or not. Grades get higher, and things just get a little bit easier. So if you just make it through this week, then I'm not saying you're going to coast the rest of the way, but it's not like I'm going to keep ratcheting up the tension indefinitely. You'll be working in pairs. One reason the grades go up is because the TAs are tired. And I stopped asking them to do so much. And anyway, you should be able to start to see the light at the end of the tunnel. I realize today's a bad day to say that, because right now it must seem overwhelming. It'll be okay. I'll see you next week.